Hello, everybody, and this is Mr. Folly, and welcome to 5.2, where we're going to learn how to identify and predict products. So let's hop right into it. All right, so synthesis reactions. There's two simple things, elements, that combine to make a compound. A plus B makes AB, right? Two simple things, one big one. We're going to balance the charges for the products, okay? And we're going to watch for diatomics in the elements. So what do I mean by balance the charges? If I have H2 plus O2, I know I'm going to have H and O, right? H is plus 1. What? How to get my charges again? Plus 1, plus 2, plus 3, 0, minus 3, minus 2, minus 1, 0. Dropping those little columns in there. So hopefully that'll ring a bell. Hydrogen is right here, which is why it's plus 1. Oxygen is right here, which is why it's minus 2. Okay, so this will turn into H2O. So lithium plus Cl2 will give me LiCl. Notice, don't carry subscripts. Okay, so in this case, lithium is plus 1, chlorine is minus 1. They balance. I'm all done. See how we're using our naming stuff back? Yeah, we are. Decomposition. One thing turns into elements if we predict the products. It can be smaller compounds if you're just identifying the type. So if you're just identifying the type, it can be smaller. But if we have to predict the products, it's just going to be elements. AB turns into A plus B. Watch for diatomics. For the products, remember, Hunkelbreath. So NH3 turn into its elements, N plus H. And consider diatomics. Nitrogen's diatomic, it's a 2. Hydrogen's a diatomic, it's a 2. CO2 turn into its elements, CNO, C plus O. Carbon, not diatomic. Oxygen is diatomic. Boom. CaCO3 for us. You get calcium plus carbon plus oxygen. And the only diatomic I have is oxygen. All right, so now what you did a little bit of online labbing with today is single replacement. Elements in compound react to form an element in a compound. AB plus C yields AC plus B. So notice C's got to be more attractive than B and kick it out. Okay? So these things have to have the same charge. So the things replaced, so the switches need same charge, just the positive or the negative part. So notice here, non-metals are negative, metals are positive, and this tells us the pecking order. Okay, so for example, if some movie, so this is Happy Mr. Folly and Mrs. Folly, along comes a famous pop star, oh I know, Lil Wayne. So Lil Wayne comes along, and Lil Wayne is going to kick me out. Oh, so what happens now? Mrs. Folly and Lil Wayne, and poor little Mr. Folly off here by myself. Why is that? Because Lil Wayne is, I asked somebody for the most attractive celebrity, and they shouted out Lil Wayne. So see how up on top, this is Lil Wayne. So Lil Wayne is on top, right? So anything on top will replace anything below. Lil Wayne can steal anybody's Lil Honey, right? So let's take a look. Okay, so this is the activity series. You'll be given the activity series on your test, given test. This means that F can replace Cl. It's higher up, right? And NaCl, okay? But Cl cannot replace F. I cannot steal Lil Wayne's girlfriend. I think we all know that. It's a shock to some, but it's true. So in this case, Cl cannot replace F. Now notice, Cl is trying to replace F because negatives can replace negatives, and that's it. Okay, we still have to watch for diatomics, see how chlorine is diatomic, and we still have to balance the charges. We always have to balance the charges. All right, so let's take a look. MgCO3 plus Li, so that's going to give me LiCO3 plus Mg. Li is a positive, it's going to try and replace Mg. Lithium is plus 1. and carbonate is -2, so Li2CO3 plus Mg. Only if lithium is above magnesium. Hey, Lil Wayne, lithium is above everything, right? So this one does happen. Okay. F2 plus LiBr. F. What is F going to try and replace? Is F going to try and replace lithium or bromine? Well, here's F. It's going to try and replace bromine. F is above Br, so it will happen. So LiF plus Br. Okay, I need to check my charges. Lithium from the periodic table is +1. Fluorine from the periodic table is -1. That's balanced. And bromine is diatomic. All right, Hunkelbrief. Zinc plus copper nitrate. So I got to see, can zinc, I know that's a metal and it's positive, can zinc replace copper? Can zinc replace copper? Zinc can replace copper. So that means I'm going to get ZnNO3. Notice how this 2 is because of copper. So I'm going to leave that off for a bit. And then copper is going to be all alone. Okay. So zinc from the periodic table, it's one of those always metals, and nitrate is -1. So to balance the charges here, it takes 2 NO3 negatives to balance +2. Remember, I can never leave my charges on there, and I'm good. So remember, single replacement, you've got to check the activity series. Oh, I got one more. This is kind of the flip-flop. Remember how we had zinc up here and copper down here? Copper can't do it. Copper is too unattractive. It's too Mr. Foley, not enough Lil Wayne. So what do we write when it's no reaction? We write no reaction. Now, you don't have to say why, but it is true that Cu is below. Why did I misspell below? Below zinc. Or it's less active than zinc. So how do we figure this out, by the way? That lab you're doing kind of right now in class. So that's it. Double replacement. This is the long one. And solubility rules are on the next page. So we've got our solubility rules here. That's these. Okay. So let's take a look. Double replacement. 2 aqueous solutions form a precipitate. A precipitate is abbreviated PPT. It's a solid that forms an aqueous solution. Solid is the same thing as precipitate, is the same thing as insoluble, and I'm going to add is the same thing as a down arrow. Aqueous is the same thing as soluble, it's the same thing as no precipitate, and it looks liquidy, but isn't just a liquid. An aqueous solution is something that's dissolved in water, not melted. Salt water is aqueous NaCl. Melted salt is over 1,000 degrees. So dissolving salt in water makes it aqueous. Heating up salt until it melts is not aqueous. So here we go. Notice, A is in the front, A is in the front, C is in the front, C is in the front. And all that happens is whoop-de-doop-de-doop-de-doop-de-doop, switcheroo. Okay? So we have to balance the charges of our products. Not all products form precipitate, only the ones that are more attractive to themselves than water. And examples using the solubility rule. So let's take a look at PbSO4. PbSO4 is a solid. Okay, so let's look at our solubility rules. Group 1 ions. So on our periodic table, the group 1 ions are these guys. That's not H. Are always soluble. NH4 positive is always soluble. Nitrates are always soluble. Most acetates are always soluble. Okay, then it gets a little bit meaner. Then we get chlorides, bromides, fluorides, iodides are soluble. Exceptions are these guys. So notice how it's most. Most sulfates are soluble. Noticeable exceptions are these. Oof. Most hydroxides are only insoluble, unless they meet the above rules. And then these other ones, most of these things are only slightly soluble, insoluble for our purposes, unless they're soluble from above. And then assume everything else is a precipitate. So let's take a look. So my first question is it group 1? So lead on the periodic table is not a group 1 ion, right? Group 1, we showed you where that was. Lead is like right here, not group 1. So then I need to look for my sulfate rule. My sulfate rule is right here. Most sulfates are soluble except lead. So that means it's insoluble. Okay. Most sulfates are soluble. Lead is an exception, so we write as PbSO4 solid. LiOH. First question. Is it group 1? Yes. Li is group 1. But if you did, okay, so if you did, so right away we say it's aqueous. So that means right away I know it's LiOH, aqueous. If you did, most OHs are soluble unless they meet the above rules, which is the same ones. Okay? All right, combustion reactions. Oh, by the way, I forgot to say this. Balance the charges. Double replacement must form a precipitate or water. Combustion reactions. Products are always CO2 and H2O. It's burning, which means you also get light and heat. So there's usually a hydrocarbon, C's and H's, maybe O's, reacting with oxygen to form carbon dioxide and water. Okay? Can be anything reacting with oxygen to form the most common oxide. This you can even kind of forget a little bit. This is true, but not on the test. So let's take a look. I've got C's and H's plus O2, and I make CO2 and H2O. That's combustion. C's and H's and O's plus O2. Thank you.
Thank you.
Here, you got it.
Thank you.
Mm-hmm. So let's look at some examples now. CH4 plus O2. It's hydrocarbon plus oxygen. I get CO2 plus H2O. Crazy. C's, H's, O's, H's. I get CO2 and H2O. I put H2O plus CO2. That's the same thing. C2H6 plus O2. Hydrocarbon. CO2 plus H2O. I want to warn you, this looks a little bit like single replacement, doesn't it? Where I have a compound, AB plus C, right? But you got to make sure that you can identify hydrocarbons. Okay? Let's take a look at common mistakes. When do we use the activity series? Activity series only for single replacements. Only for single replacements. Only for single replacements. Do not use it for anything else. Okay? And note, there can be no reaction if the solo element is below the element in the compound. That was up there too. When to use your solubility rules? Only for double replacement. Only for double replacement. Only for double replacement. To be a reaction, you must form one precipitate. And I got to add this. Or water. H2O counts as well. I know water is a liquid, not a precipitate. You need to remember to balance the charges for every compound. Balance the charges for every compound. Balance the charges for every compound. And watch out for diatomics. And that is it, to which I will say, hey, Evan, you want to say it?
What's up?
Oh, never mind. Toodles.